Hello students, welcome to this third video on vectors. So let us continue solving the worksheet problems. So now the seventh question. The line L1 is represented by the vector equation R equal to, so we have first equation L1, first line L1, the equation is R equal to -3, -1, 25 plus P times 2, 1 and -8. Okay. Now our second line L2 is parallel to L1 and passes through the point B -8, -5 and 25. So there is a point P with coordinates -8, -5 and 25. Let's say for example if this is line L1, okay, this is L1, then obviously this point will be -3, -1, 25, and the parallel vector will be 2, 1 and -8. Okay, now it is given that the second line L2, there is another line L2, this is parallel to L1, so this is L2 parallel to L1 and it passes through the point -8, -5, 25. Okay, so you need to find the equation of L2. Quite simple. So L2 is nothing but R, or maybe we can write bold R, so which means we don't have to write the vector sign. So R equals, a vector will be -8, -5, 25 plus T. Now the direction vector is nothing but, since this line L2 and L1 are parallel, I can use the same vector as the direction vector of L2 also. So I can write it as 2, 1 and -8. So this is the equation of L2. And so fine, that is done. A third line L3 is perpendicular to L1 and represented by, okay, there is a third line L3. It is given by R equal to 503 plus Q times -7, -2 and K. Okay, so this is the equation of third line, and it is given that L1 and L3 are perpendicular to each other. That means L1 is perpendicular to L3. So you need to show that the value of K is -2. Okay, now we know that if two lines are perpendicular, then the direction vectors are perpendicular to each other. Now for example, here for the first line this is the direction vector, and for the third line this is the direction vector. So these two vectors are perpendicular to each other, right? So these two vectors are perpendicular to each other. Now if two vectors are perpendicular, we know that the dot product is 0, right? So definitely the dot product of these two vectors is 0. So let me find it. Let's say, let me draw here. So if I win the dot product, you'll get 2 into -7 plus 1 into -2 plus -8 into K equal to 0. So you'll get -14, -2, -8K equal to 0. So you'll get -8K equal to +16, which means K equal to -2. So that's done. The value of K is -2. Okay, the next part is the lines L1 and L3 intersect at the point A. Find the coordinates of A. Fine. So the point of intersection of two lines. I need to solve L1 and L3. So okay, let me erase all these, the rest of the questions. Fine. These are the two lines L1 and L3. Now I need to find the point of intersection. The first thing is you need to equate both. You need to equate this. So for example, -3, -1, 25 plus P times 2, 1, -8 equal to 503 plus Q times -7, -2 and -2. Okay, in case if we get the wrong answer, at least you will get some step mark. So this particular step will fetch you definitely 1 mark for writing this. Okay, next is getting the 3 equations. In fact, you can get only 2 and then solve them. So let me say if I take the first one, so that means minus 3 plus 2p equal to 5 minus 7q. So which will give me 2p plus 7q equal to 8, equation 1, right? And the second equation is minus 1 plus p equal to 0 minus 2q, so minus 2q. So you'll get p plus 2q equal to 1. Okay, now you can stop it here. No need to find the third equation. So I'm going to solve 1 and 2. So I'll keep the first one as it is. That means 2p plus 7q equal to 8. And second equation I'll multiply by 2. So I'll get 2p plus 4q equal to 2. Okay, so if you subtract, you'll get 3q equal to 6. So which means q equal to 2. Yeah. Now substitute the value of q. So the x coordinate is nothing but here. This is the x coordinate. So 5 minus 7 into 2. So 5 minus 14 is minus 9. The y coordinate is minus 2q. So minus 2 into 2. So minus 4. And z coordinate is nothing but 3 minus 2q. So 3 minus 2 into 2. So minus 1. So the coordinates of A are minus 9, minus 4 and 1. Not minus 1, it is minus 3, minus 4 and minus 1. Yeah. Fine. Now, even though I got the correct answer, now you can see that I made a small mistake here again. When I copied this as plus 25. It is actually minus 25. Right? So that's it. So this is the answer, minus 9, minus 4 and minus 1. Now it is given that L2 and L3, let's say this is L2 and this is L3, they intersect at the point C, and where BC is equal to 6, 3 and minus 24. So the first thing is find AB. Find AB vector. Right? So AB vector, how do you find it? Okay. So this is nothing but OB minus OA. Now B is, or OB we know. OB is minus 8, minus 5 and 25 minus OA. Just now we found the point A, right? So you got minus 9, minus 4 and minus 1. So this will give me minus 8 plus 9 is 1, minus 5 plus 4 is minus 1, and 25 plus 1 is 26. Okay, so this is AB vector. The next part is find the magnitude of AC. Now to find the magnitude of AC, I need AC vector first, right? So AC vector is equal to AB plus BC. As you can see, AC, so A starts, it ends at C, and in between B and B are same. So AB is nothing but 1 minus 126 plus BC is already given 6, 3 minus 24. So if you add them, you'll get 7, 2 and 2. So magnitude of AC is nothing but square root of 7 square, which is 49, square root of 2, square of 2 plus square of 2. So you'll get square root of 57. So you can use the calculator to find this answer correct to 3 significant figures. Yeah, very simple. Let me find it. So it is approximately equal to 7.55. Yeah, so this is done. Let us solve the next problem now. Fine. It's mentioned that points P and Q have position vectors. Okay, so OP vector is equal to minus 5i cap plus 11j and plus minus 8k. which means I can write like this: minus 5, 11 and minus 8. So this is OP vector, and OQ vector is given in terms of I, j and k. I can write it as minus 4, 9 and minus 5. So I think I prefer writing in this form, and both lie on line L1. Okay, so find PQ first. So PQ is OQ minus OP. So which means you'll get minus 4 plus 5, which is minus 1, 9 minus 11, which is minus 2, minus 5 plus 8, which is 3. So you'll get minus 1, I'm sorry, minus 4 minus plus 5, right? So you'll get 1, 1 minus 2 and plus 3. So that is PQ. Hence, show that the equation of L1 can be written as R equals minus 5 plus S times I plus 11 minus 2S J plus minus 8 plus 3S into K. Now it may look confusing, but it's very simple. Let me find the equation of R in like how we normally find. So R equal to A plus TB. So I can write, I'll take A as minus 5, 11 and minus 8 plus yes. I'm using yes because you can see minus 5 plus S, 11 minus 2S is this. So I'll take yes. And since the line L passes through P and Q, I can take PQ vector as a direction vector. So that means 1, minus 2 and 3. Right? So this can be written as, students, minus 5 plus S, 11 minus 2S minus 8 plus 3S, right? And R is nothing but X, Y and Z, right? Or I can just simply keep it as it is. So R vector equal to, now if I want to write this in terms of I, J and K, then I will write it as minus 5 plus S into I plus 11 minus 2S into J plus minus 8 plus 3S into K. Like for example, I wrote in IJK in this form, isn't it? Same way you can do the other way also. So that's done. So this subdivision is proved. Fine. It is given that the point R to Y1 Z1 lies on this line L1. Okay, lies on this line. This lies on this line. Lies on this line. So find the values of Y1 and Z1. So very simple. What you need to do is you need to equate minus 5 plus S equal to 2. So minus 5 plus S equal to 2. So S is nothing but 7. Right? So Y coordinate is nothing but this 11 minus 2S. So Y1 is 11 minus 2S. So 11 minus 2 into 7. So minus 3. And Z1 is nothing but minus 8 plus 3S. So minus 8 plus 3S. So minus 8 plus 3 into 7. So 21 minus 8 is 13. Fine, that is also done. So Y1 is minus 3 and Z1 is 13, students. So basically it means the point R is 2, minus 3, 13. The coordinates are 2, minus 3 and 13. Okay, the line L2 has the equation is given here. Let me erase the rest. Fine. So the line L2, has the equation R equals 2I plus 9J plus 13K plus T times, where is this? I plus 2J plus 3K. Fine. And if you want, if you think it is confusing, you can write it in this form, like 2, 9 and 13 plus t into 1, 2 and 3. Okay. The lines L1 and L2 intersect at a point T. Find the position vector of T. That means you need to solve this and this. Okay. Now I'm not going to do that, student, because it's quite simple. We have already done 2 problems of that type, so you can solve them yourself and find the answer. Okay. And finally, find the angle between L1 and L2. So again, this is the direction vector for the first line. This is the direction vector for the second line. Now when you actually look at it, students, like 1, 2 and 3, here it is 1, minus 2 and 3. So no, I don't think the dot product is 0. So you can use the formula. So this is, you can take it as A vector, and this vector you can take it as B vector. So the formula is cos theta equal to A dot B divided by magnitude of A into magnitude of B. So you can magnitude into magnitude. So you can use this formula to solve the problem. Yeah, quite simple. I'm not going to do it. So let us go to the next problem. Problem number 9. Fine. The position vector of point A is 2i plus 3j plus k. So I will write it as OA equal to 2, 3 and 1. And the position vector of B is given. So OB is 4, minus 5 and 21. So maybe for me it is more comfortable writing like this, even for you also. So show that AB equal to 2i. So you need to show that AB equal to 2i minus 8j plus 20k. Okay, let me find it. So AB is nothing but OB minus OA, isn't it? So that means 4 minus 5, 21 minus 2, 3 and 1. So you'll get 2 minus 8 and 20. So this can be written as 2i minus 8j plus 20k, right? So that is proved. Find the unit vector u in the direction of AB. So u is nothing but 1 by magnitude of AB, a unit vector in the direction of AB into AB, right? So let me find the magnitude of AB. So magnitude of AB is square root of, you square the components, add them, and then take the root of that sum. So 4 plus 64 plus 400. So you get square root of 468. So the answer is u is equal to 1 by square root of 468 multiplied with 2 minus 8 and 20. So this is the answer. You can simplify it further, of course. You can find the square root of 468 and you can leave it there, or you can leave it there. Okay. Show that u is perpendicular to OA. Fine. So I need to prove that this vector is perpendicular to this vector. So how do you show that? We know that if the dot product of two non-zero vectors is 0, then definitely they have to be perpendicular, isn't it? So let me find the dot product. So 2 into okay, so what will you get is, I'll get 2 into okay, this vector can be further written as, in case if you want, 2 by root of 468 minus 8 by root of 468 and 20 by root of 468, right? So I can 2 into 2 by root of 468 plus 3 into minus 8 by root of 468 plus 1 into 20 by root of 468. So you'll get so root of 468 is common in the denominator. You'll get 4 minus 24 plus 20 So you'll get 0 by root of 468, which is nothing but 0. Therefore, U is perpendicular to OA. U vector is perpendicular to OA, that is shown. The next one is let S be the midpoint of AB. Fine. So we have AB here. So let me erase the next rest of the problem. So fine. It is given that S be the midpoint of AB. So the coordinates of S are 2 plus 4 by 2, comma 3 minus 5 by 2 and 1 plus 21 by 2. Right? These are the coordinates of S. That means I'll take the average of this, and average of 1 and 21. So you'll get 3, minus 1 and 11. So these are the coordinates of S. Now the line L1 passes through S and parallel to OA. So first point is find the position vector of S. So the position vector of S is this. This is the position vector of S. So OS equal to 3 minus 1, 11. So this is the position vector of S. Write down the equation of L1. Okay. Now it is given that the line L1 passes through S and parallel to OA. That means L1 is nothing but R equals passes through S, so 3 minus 1, 11 plus let me use a variable. Let me use, let's say, T times 2, 3 and 1. Yeah, fine. Now the L2, there is another line L2 which is R equal to 5i 10j 10k, so I can write it as 5, 10 and 10 plus S into minus 2, 5 and minus 3. Fine. So there are two lines L1 and L2. Now you have to explain next subdivision. The C part is explain why L1 and L2 are not parallel. So if you recall, I explained that in the first video. If two vectors are parallel, if two lines are parallel, then the direction vectors also need to be parallel. Now this is the direction vector of the first line and this is the direction vector of the second line. Now do you think these two vectors are parallel, students? They are not parallel, isn't it? Because if two vectors are parallel, their components will be proportional. That means, for example, let's say 2, 1 and 4 and multiply everything by, let's say, 3, 6, 3 and 12. Now these two vectors will be parallel, right? These two vectors will be parallel, but not these. So how do we prove that they are not parallel? We know that they are not parallel. How do you prove it? Just show that they are not proportional. So what you need to do, right, is minus 2 by 2. That means this divided by this is not equal to 5 by 3. This divided by this. So done. So they are not proportional. So hence they are not parallel. So the final subdivision is the lines L1 and L2 intersect at the point P. Find the position vector of P. So you need to find the point of intersection of this line and this line. I'm sure you know you know how to find the answer for this. So equate both the lines and then get two equations in T and S, solve them, and then find the point of intersection. But important thing is, suppose you get this answer, let's say 1, minus 2 and 6 as, I don't know, but just in case you get this answer as the point of intersection. If you leave it there, you are going to lose 1 mark, students, because if you read the question properly, it is mentioned find the position vector of P. They're not asking you to find the coordinates of P. Find the position vector of P. So your answer should be 1, minus 2 and 6. Provided this is the point of intersection, right? So fine, I think this sum is done. Let us go to the 10th problem now. Fine. Problem number 10. The point O has coordinates 0, 0, 0, which you know the origin. A has coordinates 1, minus 2 and 3. So A has coordinates 1, minus 2 and 3. And B has coordinates minus 3, 4 and 2. So B has minus 3, 4 and 2. Fine. Show that AB equal to, so I need to find AB. So AB is OB minus OA, so minus 3, 4, 2, minus 1, minus 2, and 3. So which will give me minus 4, 6, minus 1. So hence proved, that is done. Find BAO. You need to find BAO. So how do you find it? Let me draw the diagram here. So let's say, like, I don't know, I just drawn an obtuse angle, but I don't know whether it is obtuse or acute, but BAO. Okay, I need this angle BAO. That means cos of BAO equal to AB dot AO by magnitude of AB into magnitude of AO. So AB dot AO, so AB is, so I'll write AO here. So AO is nothing but minus 1, 2, and 3, isn't it? Minus 1, 2, and minus 3. Because OA is 1, minus 2, and 3. So AO should be the negative of that. Minus 1, 2, and minus 3. So AB dot AO. So we have AB here and we have AO here. Let me find the dot product. So you get minus 1 into minus 4 plus 2 into 6 plus minus 3 into minus 1 divided by a magnitude of AB, which is square root of 16 plus 36 plus 1 into square root of magnitude of AO, which is 1 plus 4 plus 9. So in the numerator you get 4 plus 3 is 7, 7 plus 12 19, so you get 19 divided by square root of 53 multiplied with square root of 14. So angle BAO is nothing but cos inverse of this. So the answer is 0.7988. So 0.799 radian. Okay, that's done. Now the second part of the problem. Next part of the problem. Fine. This is the equation of L1, students. The equation is xyz equal to minus 3, 4, 2 plus s times minus 6, 4, minus 4, 6 and minus 1. Now you need to find, they are asking you to find, write down the coordinates of any 2 points on L1. Any 2 points on L1. So in fact, as you know, by giving different values for s, I get different points on L. So let me take s as 1. Then I'll get, what is it? Then you'll get minus 3, 4, 2 plus minus 4, 6 and minus 1. So if you add them, you'll get minus 7, 10 and 1. So the one coordinate is minus 7, 10, 1. And of course the other coordinate is, you can take this point, yeah, isn't it? This vector. So other point is minus 3, 4 and 2. Yeah, so these are the 2 points which lie on L1. Of course there are infinite points which will lie on L1, but since they are asking you to find only 2 points, we can stop here. Now the next subdivision is, the line L2 passes through A and is parallel to OB. Okay, so L2 is R equal to, it passes through A. So we know that the point A is 1, minus 2, 3. So the A vector is 1, minus 2, 3, the position vector, plus, since we already used S, let me use T here, and it is parallel to OB. Now B is minus 3, 4, 2. So OB is vector minus 3, 4 and 2. So this is the equation of L2. Okay. Now it's given that the point C is on L2. The point C, which is K, comma minus K, comma 5, lies on L2. It lies on L2. So find the value of k. Now I can write this as 1 minus 3t minus 2 plus 4t and 3 plus 2t. And students, this is the x coordinate of any point on line L2. This is the y coordinate and this is the z coordinate of any point on the line L2. Now it is given that the point C lies on L2. That means the z coordinate is 5. So I can equate 3 plus 2t equal to 5, which means 2t equal to 2, which means t equal to 1. Therefore, k is nothing but the x coordinate, which is 1 minus 3t. So 1 minus 3, which is minus 2. So the value of k is minus 2. And but the question is find the coordinates of C. So the coordinates of C are minus 2, plus 2 and 5. Right? Okay. Finally, the last part of the question. The line L3 has equation. So let me erase all these three. Fine. The line L3 has equation xyz equal to 3 minus 80 plus p times 1 minus 2 minus 1 and passes through the point C. Find the value of p at C. Now we know that the coordinates of C are minus 2, 2 and 5, right? And it says that it passes this line L3 passes through the point C. So find the value of p. Very simple. I can write this as 3 plus p minus 8 minus 2p, 0 minus p, right? So this is the x coordinate, y coordinate and z coordinate. So equate 3 plus p, equate the x coordinates equal to minus 2, so p equal to 5, minus 5. So the value of p is minus 5. Yeah, that's done. So the sum is over. Fine. The last problem for this video, the problem number 11. The line L1 and L2 are given by R1 equal to, this is line L1, so 9, 4, minus 6 plus S times minus 2, 6 and 10. So R2 equal to 122 plus T times minus 6, 10 and minus 2. Okay. Let theta be the acute angle between L1 and L2. Show that cos theta is 52 by 140. Okay. Let me find cos theta. Cos theta is nothing but, you know the formula. So this is the direction vector for the first line. This is the direction vector, sorry, for the second line. So find the dot product. So minus 2 into minus 6 plus 6 into 10 plus 10 into minus 2 divided by magnitude of this, so which is square root of 4 plus 36 plus 100 into square root of magnitude of this, which is 36 plus 100 plus 4. So which is nothing but 12 plus 60 minus 20 by square root of 140 multiplied with square root of 140. So which is nothing but 52 divided by 140. Hence proved. So that is done. The next one is P is the point on L1 when S equal to 1. Okay. So this is L1. This is L1. Now when S is 1, what do you get, students? You will get R1 equal to 9, 4 minus 6 plus minus 2, 6 and 10. So which is nothing but 7, 10 and 4. So when S is 1, you get this position vector, and that is the position vector of the point P. So that is OP vector. Okay, so that is also done. Show that P is also on L2. So we need to show that the point P also lies on L2. Okay, how do you show that? So what you need to do is, let me erase this. Fine. Take the point P. So take the position vector of P, which is 7, 10 and 4. 7, 10 and 4, and equate it to this. That means 1, 20 and 2 plus T times minus 6, 10 and minus 2. Fine. So when I equate it, you'll get 7 equal to 1 minus 6t. So 10 equal to 20 plus 10t, and 4 equal to 2 minus 2t. So if you solve this, you'll get t as minus 1. Here also you'll get t as minus 1. Here also you'll get t as minus 1. So hence proved, right? So since the values of t are same, definitely the point P also lies on L2. Fine. The third line L3 has direction vector 6x and minus 30. Okay. So let me erase this. There's a third line L3 which has direction vectors. That means I can write like this. Let's say R3 equal to some vector plus some, I've already used TNS, let's say some P times 6x and minus 30. Okay, so this is line L3. Now if L1 and L3 are parallel, so let me write the equation of L1. So equation of L1 is R1 equal to 9, 4 minus 6 plus S times minus 2, 6 and 10. So it's given that L1 and L3 are parallel. What should be the value of K? Quite simple. Now if they are parallel, then the direction vectors have to be proportional, isn't it, students? That means 6 by minus 2 should be equal to x by 6 should be equal to minus 30 by 10. So basically you'll get minus 3 equal to x by 6 equal to minus 3, which means x equal to minus 18. So the value of x is minus 18. Fine. Okay, fine. I think whatever problems are solved in this video, you are very clear as to how to solve those kind of problems. Fine. Good. Thanks for watching these videos, student, this particular video, and maybe we have to do the rest of the problems in another video. Yeah. Thank you.